Good morning, students. Jai Swaminarayan. Today we are going to start a new topic of tangent and normal. Students, today we are going to start a new topic of equations of tangent and normal. Now, students, in 11th standard, all of you have studied the basis of straight line. Say, students, this is an curve. And let us suppose that the equation of the curve is y is equal to fx. So this is the equation of a curve. So on the curve we have a point P, x0, y0. Therefore definitely this point P satisfies the curve. So we can write y0 is equal to f of x0. Now we want to find equation of tangent at the point P x0, y0. Now geometrical interpretation of derivative is slope. So slope of tangent would be, students, slope of tangent would be n is equal to dy by dx, and that is nothing but f dash x. So slope at particular point P will be nothing but f dash of x0, and let us suppose this is f. So if we have point and slope, recall point slope form of the line. So y minus y1 is equal to n into x minus x1. This is the equation of tangent to the curve. Y is equal to f of x at any point, say P x0, comma y0. This is the equation of tangent to the curve. Y is equal to f of x at any point, say students, P x0, comma y0. Now normal is always a line perpendicular to tangent. So if slope of tangent is n, slope of normal would be minus 1 by n, and equation of normal would be y minus y0 is equal to minus 1 by n into x minus x0. Students, this is the equation of normal to the curve. Y is equal to f of x, students, at the point P x0, comma y0. Students, this is what we have to remember and memorize and apply these students to the sums. So as such, no new formulas. All of you know that if the tangent is horizontal, then slope of a horizontal line is 0. In such a case, the equation of tangent would be y is equal to y0. And when slope of tangent is 0, slope of normal will be undefined. In that case, normal will be a vertical line. So all of you are aware of the concepts that slope of a horizontal line is 0 and slope of a vertical line is, students, undefined, not possible, because tan of 90 degree is undefined. So in short, this much only, students, we have to memorize and remember for the theories of tangent and normal. In short, students, this much only we have to remember and memorize for the theories of tangent and normal. Geometrical interpretation of derivative is, students, you can say slope. Now let us start exercise 6.3, sum number 1. I am starting, students, exercise 6.3, some number 1. Now, all of you pay attention. In exercise 6.3, students, we are starting with some number 1. Find the slope of tangent to the curve y is equal to 3x raised to 4 minus 4x at x is equal to 4. So the given curve, let us write, the given curve is y is equal to f of x is equal to 3x raised to 4 minus 4x, and it is at x is equal to 4. Now, slope means dy by dx. So first I will find n is equal to dy by dx is equal to 12x cubed minus 4. So slope at x is equal to 4 will be n is equal to 12 into 4 cubed minus 4. So this will be 12 into 64 minus 4. Simplify, students, whatever you get, that is your answer. Now this is very easy. I expect you to simplify and get the answer. Okay, students, answer 2. Find the slope of tangent to the curve. So given curve is, students, given curve is y is equal to f of x is equal to x minus 1 upon x minus 2. Of course, x not equal to 2. We have to find slope of tangent at x is equal to 10. Okay, now students, to find slope, we need to find derivative, because the geometrical interpretation of derivative is nothing but slope of tangent to the curve at the given point of contact. So students, if I operate dy by dx, then I have to apply division working rule. Denominator as it is derivative of numerator, numerator as it is derivative of denominator upon denominator square. Simplifying, x and x gets cancelled, so we will have x minus 2 minus x plus 1 upon x minus 2 the whole square. So this is minus 1 upon x minus 2 the whole square. Now, slope of tangent at x is equal to 10 will be n is equal to 10 minus 2, 8 square, so minus 1 by 64. So if you are told to find, student, slope of normal, then it will be reciprocal with a negative sign, so it will be 64. Just I am explaining that here, suppose students, if you were told to find slope of normal, then students, the slope of normal will be 64, because tangent and normal are perpendicular lines, and all of you know, for two lines to be mutually perpendicular, the product of their slope is minus 1. Okay, students, now let us do the next set of sums, answer 3 and 4. Okay, students, I am erasing this much. Okay, answer 3 and 4. Let us see what the question is. Find the slope of tangent to the curve y is equal to x cubed minus x plus 1. Y is equal to x cubed minus x plus 1, whose x coordinate is 2. So at x is equal to 2. Okay, I am noting down the fourth question also, then we will do at a time. Find the slope of tangent to the curve y by whose x coordinate is 3. Y is equal to x cubed minus 3x plus 2. And x coordinate is 3. These are, I should say, very simple and altogether elementary, you can say, sums. These are very simple and elementary sums. Now students, if I operate dy by dx, then slope n is equal to dy by dx, and that is 3x square minus 1. Slope at x is equal to 2 will be n is equal to 3 into 2 square minus 1. 4 into 3, 12 minus 1, which is 11. Now students, nobody will ask you this type of questions, but it is to demonstrate the fact that geometrical interpretation of derivative is slope of tangent at the point of contact. So students, slope of normal will be reciprocal with the negative sign minus 1 by 11. Here, derivative n, slope n is equal to dy by dx is equal to 3x square minus 3. Slope at x is equal to 3 will be n is equal to 3 into 3 square minus 3, so 27 minus 3, which is equal to 24. So slope of normal, if asked, slope of normal if asked to be minus 1 by 24 students. If you would have been asked to find slope of normal in the fourth sum, it would be students minus 1 by 24. So again, these are elementary sums, but you should understand the method and logic of the sum. Okay students, now question 5 and question 6 we are doing. Okay, the curve changes. So here let us write whatever the given curve is. So students, question 5, the curve is given in parametric form, and all of you have already studied the derivative in parametric form. X is equal to a cos cube theta and y is equal to a sin cube theta, and we have to find slope at theta is equal to 5 by 4. And here we have to find slope of normal. Okay. Here students, we have to operate slope of normal. Let us do the sixth sum. Given curve x is equal to 1 minus a sin theta and y is equal to b cos square theta. We have to find that theta is equal to pi by 2 slope of normal. So now the phase of the sum changes students. From this sum onwards students, we have to find, you can say, the slope of normal. We can never directly get students slope of normal. First we have to find slope of tangent, and after that only students we can get slope of normal. Now derivative is in parametric form. So first of all, to find dy by dx, I have to operate dx by d theta. So 3a cos square theta into minus sin theta. This will be dx by d theta, and dy by d theta will be 3a sin square theta into cos theta. So all of you know that dy by dx is considered as ratio of dy by d theta upon dx by d theta, where dx by d theta not equal to 0. So this would be 3a sin square theta cos theta upon minus 3a cos square theta sin theta. So this would turn out to be minus of tan theta. Now slope of tangent m is equal to slope of tangent, and that would be at pi by 4 minus tan pi by 4, which is minus 1. Therefore slope of normal would be minus 1 by m, and that is 1. So indirectly shows, if you are asked to find slope of normal, first we have to find student slope of tangent, and after that only students we can operate slope of normal. So that is a very clear concept. Now students, sum number 6. If I operate dx by d theta, then this would be minus of a cos theta, and if I operate dy by d theta, it will be minus 2b sin theta cos theta. Therefore dy by dx is the ratio of dy by d theta upon dx by d theta, so minus twice b sin theta cos theta upon minus of a cos theta. So this would be twice b by a sin theta. Now m is equal to slope of tangent, and that is at pi by 2 sin pi by 2 b1, so twice b by a. Therefore slope of normal would be, students, minus of a by twice b, reciprocal of the students. So very simple, very interesting. But students, your fundamentals of derivative must be very, very sound. Here I should not teach again that if a curve is given in the parametric form as x is equal to f of theta and y is equal to g of theta, then dy by dx is the ratio of dy by d theta upon dx by d theta, provided dx by d theta not equal to 0. So students, a thorough revision or a nice revision of derivative is done here. So one should be very sound in the fundamental concepts of derivative. One must be very sound, students, for the basics of derivative in order to students do this type of sums. Now question 7 and 8 we are doing, students. All of you concentrate. Our next target is to do question 7 and 8. First 10 sums are very elementary. Find points at which tangent to the curve is parallel to x-axis. Okay, students. Given curve is y is equal to f of x is equal to x cube minus 3x square minus 9x plus 7, and tangent parallel to x-axis. This is the date. Okay, fair. Then I am noting the 8th sum. Given curve is y is equal to f of x is equal to x minus 2 the whole square. Okay, here find a point if tangent is parallel to the chord joining the 2 points. Now, strictly speaking, if I suppose this as capital X, then this is x square is equal to y. So this is a parabola, and on that parabola we are given 2 points, and we have to find a point P where tangent at P is parallel to the chord AB. This is the data. So this MVT students mean value theorem. So let's start with students mean value theorem. So indirectly students, this is the basic application of mean value theorem students in a slightly different way. Okay, students, let us go with some 7 once again and reading the question. Find points at which the tangent to the curve is parallel to x-axis. This is a cubical curve where I cannot find the exact graph, but let us find derivative dy by dx would be definitely 3x square minus 6x minus 9. Now, slope of tangent at say point P x0, y0 is n, then n is equal to 3x0 square minus 6x0 minus 9 is equal to 0. Because if tangent is parallel to x-axis, tangent is a horizontal line, and student slope of a horizontal line is 0. So if tangent is parallel to students x-axis, which tangent is a horizontal line. Taking 3 common, I will get x0 square minus twice x0 minus 3 is equal to 0. So x0 minus 3 and x0 plus 1 is equal to 0. Therefore x0 is 3 or minus 1. Now this point of contact will lie on the curve. So for x0 is equal to 3, y0 would be substitute here. So this is 3 cube minus 3 into 3 square minus 9 into 3 plus 7. So 27 and 27 gets cancelled, minus 27 plus 7, so minus 20. So the first point is P x0 y0 is equal to 3 comma minus 20. This is what students have to understand, because the point of contact will definitely satisfy the equation of the given curve. Then for x0 is equal to minus 1, y0 would be y0 is equal to minus 1 cube. So minus 1, minus 1 squared, so 1 into minus 3 is still minus 3. 9 into minus 1 will be plus 9 plus 7. So 9 minus 4, 5, 5 plus 7, 12. The third point is cube x0, y0 is equal to minus 1 comma 12. That is why students, in the question we are given points. That is why in the question students we are given points. So these are the required 2 points at which students the tangent is parallel to x-axis. Okay, let us refer the 8 sum. Find a point on the curve y is equal to f of x is equal to x minus 2 the whole square, at which the tangent is parallel to the chord joining the point 2 comma 0 and 4 comma 4. So point A is 2 comma 0. Suppose and this point is 4 comma 4. So first of all, I find slope of chord AB, which is nothing but y2 minus y1 upon x2 minus x1, and that is 2. Now we differentiate the given curve. So we get dy by dx is equal to twice x minus 2, and that is 2. Because if tangent is parallel to chord AB, then students, if tangent is parallel to chord AB, then slope should be equal to 2. So we will get x minus 2 is equal to 1. So x is equal to 3. Now this point of contact satisfies the given curve. So substituting x is equal to 3 in fx, we get y is equal to 3 minus 2, 1 square, that is 1. Therefore the point of contact is px comma y is 3 comma 1. Same students, same thing you have done in MVT, and that is nothing but mean value theorem, Lagrange mean value theorem. Same students you have done in MVT. MVT is nothing but LMVT, Lagrange mean value theorem. Okay students, now we are doing sum number 9 and 10. Okay students, next is sum number 9. We have to refer the questions in this topic very perfectly, students, so that we can understand what is the given data. Data collection, students. Data collection forms an integral part here. Let us refer the question. Find the point on the curve x cube minus 11x plus 5 at which tangent is y is equal to x minus 11. Okay students, given curve is y is equal to fx is equal to x cube minus 11x plus 5, and tangent is y is equal to x minus 11. Find the point on the curve at which the tangent is this. So indirectly point of contact will satisfy the curve as well as tangent. Now if I compare this with mx plus c, I get slope of tangent as 1. This line is slope intercept form. So even if we find slope using the formula m is equal to minus of a by b, students, it is one and the same. But if I compare this line with y is equal to mx plus c, I get slope as 1. Now differentiating from the given curve, then dy by dx would be thrice x squared minus 11, that is 1. Because slope of tangent will be same as dy by dx. So p x0 y0 is point of contact, then dy by dx at p would be thrice x0 square minus 11 is equal to 1. So x0 square is equal to 4. So x0 is plus or minus 2. Now correspondingly find y0, because y0 is equal to f of x0 is equal to x0 cube minus 11 times x0 plus 5. For x0 is equal to 2, it implies y0 is equal to 2 cube 8, 11 into 2 plus 5. So 13 minus 22, so minus 9. So the first point is p x0 y0 is equal to 2 comma minus 9. Then for x0 is equal to minus 2, it implies y0 is equal to minus 2 cube So minus 8 plus 22 plus 5. So this is 27 minus 8. So this is minus 19. So plus 19. Okay, students. So the other point is the q. X0, Y0 is equal to minus 2, 90. Now this point of contact must satisfy the tangent also. So when I take x is equal to 2, then y is minus 9. So this point satisfies tangent. And you say this equation. But when I take x as minus 2, y will be minus 13, and here we are getting y as 19. So this does not satisfy tangent. Therefore, answer is only one point P x0 y0, which is 2, minus 9. This means we have to perfectly understand the point of contact has a dual impact. Students, the point of contact has a dual impact. It will satisfy the equation of curve also, and it must satisfy the equation of tangent also. So as per the equation of tangent, the required point of contact on the curve is only 1, and it has coordinates 2, minus 9. Okay, students, I think hereby we conclude the lecture. From 10 sum onwards, students, we will do in the next lecture. Okay, students, see, do these sums twice. These are very interesting and easy sums.